So there's a list of some of the things we're going to talk about related to quadratic equations. So first of all, what's a quadratic equation look like? Well, if you look right here in the middle, this is the big deal here. X squared. It's got an x squared or y squared or something somewhere in it. Nothing any higher, nothing any lower, no fractions, no minus signs. The leading term should have an x squared in it. So, and a, b, and c are just real numbers. As long as a isn't 0, because if a is 0, then there is no x squared term. Very simple. And this is called the standard form. Everything's on one side, zeros on the other side. Standard form. Okay, make sure you're taking notes because you want to bring any questions to class too. So here we go. We're just going to take a look at a few of them. This one's a quadratic because there's the x squared. And we can rewrite it as x squared plus 0x minus 25 equals 0. There you get standard form. This one's already in standard form, and you can see the x squared there, so we're in good shape for a quadratic. And third, well, this is a little bit more mixed up than the first one was. 3x squared minus 4x. Remember, we have to have the 0, so we fix that. And there's our standard form for the quadratic. Now we'll start into this a little bit easily. The zero factor property looks a little bit complicated, but it's really not. Now we're saying a and b are complex numbers. That's no big deal. They're just numbers, period. What we're saying here is if we're multiplying two numbers together and we end up with 0, that means one of these guys is 0. Maybe both, but at least one of them is 0. That's all it says. So, using the zero factor property. Here we go. Now notice this isn't in standard form, so we'll fix that. 6x squared plus 7x minus 3 equals 0. There we got it in standard form. Now, it says zero factor property, so we'll have to factor this. And factoring it, there are the two factors. Simply, that means we've got 3x minus 1 is a number. 2x plus 3 is a number. Multiplying those two numbers, whatever they are, we're getting 0. That means one of those two guys, either this one or both, are 0. So the zero factor property says, take that 3x minus 1, set it equal to 0, and find what x you get. Also, either at the same time or a different time, take the second one, set that equal to 0, and solve for x. So there you go. They did the same thing. A little bit messy there. I'll have them apologize. So there are two x's, our two solutions, our two roots, our two zeros. Those three terms are all representing solutions for our quadratic equation. Now, there's another way we can do this. If it turns out that we don't have any x term, for example, if we had 3x squared plus, let's say 27 equals 0. If we can write it similar to this, then this whole thing becomes really easy. Now, you don't see quadratic equations looking like that too often, but if they do look like this, all you have to do is take the square root of both sides, and remember that square roots can be positive or they can be negative. So for this one, your x will have two answers. I would suggest when you're doing these, don't put the number in at first. Know you're going to get two solutions, so put x twice with equals. X equals, leave some blanks. And then this will remind you that if you get a number for here, don't forget you're not finished because you're going to get another number over here. And this one will be the square root of k, assuming k is positive. Well, not necessarily. And this one will be the same thing except it'll be the opposite. Oops, a little bit sloppy here. It'll be the negative square root of k. Notice these minus sign or subtraction minus sign is outside the square root. And that's how you do that simple one. Really nice. You can factor it. It's unlikely you're going to do that, frankly, but you can do that. This is nice to see because this might prove to be a handy trick sometime. And there we get our two solutions for x. Next. So if you see it, your quadratic looking like this, that's how you get the two solutions, or two roots, or two zeros. All three of those mean the same thing. Solution, root, or zero. Now, by zero, we don't mean that x is zero. It means that whatever we put in for x, this special number will give us a zero for our quadratic equation. So there's the solution set. These are the two solutions, one with a plus, one with a minus. And you can abbreviate it this way if you really like. Just make sure that if you write it this way, it's very legible. Because if I can't see the plus or minus like this, if it's sloppy somehow and I can't tell, I'm not going to be able to give you full credit. So I would recommend doing this, but that's up to you. And if k is positive, but if k is negative, then we get complex ones. Real, if that number out here is positive. They're imaginary if k is negative. Make a special note to yourself. Write it the way you think about it. If k is 0, there's only one solution. 0. And because you do get two solutions up here, in reality, you get two, and they're the same thing. It's a double solution. There are two zeros, two of those, but you only write it down once because 0 is 0. There aren't two zeros. So here's an example. We've got 17 instead of k. K is sort of a generic variable for a number. Now notice this is positive. Since that's positive, we're going to get two real roots. If this were a negative, I'm not going to do that. If this were negative, then we'd get two pure imaginary solutions. Now, can you pause it for a second and write down what the solutions are? It's really easy. Or maybe you can reverse this a minute or two, take a look at what we just talked about, and then come up here and write down what the solution is. And there is your solution set. Plus or minus the square root of 17. One last time, if this is really legible, fantastic. If it's not, or you're not sure, then write both these separate. Another one. Okay, this time k, if we think of it that way, is negative. That means we'll get two pure imaginary solutions, or roots, or zeros. Remember, square root of -1 is I, so the solution set is plus or minus 5i. Why? Okay, so if we take square root of -25 and negative square root of -25, those are our two solutions. Now take the first one. In the last chapter, or the last section rather, we split this up, square root of -1, square root of 25. This is just a 5 here, and this is I, so this solution is 5i. Now the nice thing about this is, if you worked out the hard part of this one, splitting this up, this one's going to be the same thing basically, except minus 5i. All right, now we're getting to something that's not quite the same, but yet a little bit different, or a little bit the same too. So this time, instead of x squared, we've got x minus 4 squared. Well, don't let that confuse you. Instead of x, you've got this. So your two solutions are going to be x minus 4 equals, and remember I said write it down twice, that way you don't forget the two solutions. And you'll have the square root of 12 here. You'll have negative the square root of 12 there. Now we're going to do the hard work over here, and then that'll make it easy over there. So x minus 4 equals, now 12 can be written as 4 times 3, and we care about that because this works out even. So we have the square root of 4, square root of 3, so we have x minus 4 equals 2 square root of 3. Now we can fast forward over here. We've done the hard work. This x minus 4 will equal negative 2 square root of 3. So finish this up, add 4 to both sides, and one solution is 4 plus 2 square root of 3. And over here, x equals, you can see what's going to happen. It's very similar. 4 minus 2 square root of 3. You've got your two solutions. What would be really interesting, and because you have calculators, you can do this really easily. If you take the 4 plus 2 square root of 3 and store it in x in your calculator, then type in x minus 4 squared, and you should get a 12. That's a check on this one, and it's the easy way to check. And over here, we can put 4 minus 2 square root of 3, put that into x, type this in again, and we should get 12 the second time as well. So both solutions are good. By the way, notice again, the PowerPoint people put something dumb in here. This should be a times, and somehow it was left out, or just not put there properly. So we come to something that, to be very honest, some students really don't want to do this, but it's not that hard if you follow the steps. And we're going to do 1 or 2 here, and if you like, we'll do some more in the classroom until you get the steps down properly. So, how do you do this? Well, we can read through this. First of all, if a is not 1, in other words, if this isn't a 1, if it's not just x squared, divide both sides of the equation by a. That way you'll end up with the equation looking like this. Now, make sure the constant term is alone on one side of the equality symbol. So you'll end up with x squared blank 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 and whatever your number is over here. So if you've got a plus 6 over here, move it to the other side. If you've got a 19, move it over to the other side. So you're going to have an x squared term, and this is just a blank, an x term, and you're going to leave a blank right here. This is a blank. And you're going to fill this in yourself. And over here, whatever that was, you'll just drag that along. You're going to square the coefficient of x, square half of it, add the square to each side, and so on. Well, that doesn't make much sense to you, right? So let's actually try one. Here we go. We've got one to play with. So x squared minus 4x minus 14 equals 0. Number one thing to notice, this is already 1x squared, so one step is already finished. The next step is negative 14 here, get rid of it. We need the space. So add 14 to both sides. And this is what we've got. Now I'm going to have to perform some magic here. I'm going to change the color of the ink to blue so you can see what I'm adding. So what I'm going to do is I'm going to take the number in front of the x, the coefficient of x, over here, negative 4. First of all, I'm going to divide it by 2, and then I'm going to square the answer. So what do I get? Just working on this, this will be 16 fourths, or 4. Now what we're going to do with this number, remember we took half of the number here and then squared it. And that number we're going to add to fill in the blank. And to keep things equal, we'll add it to both sides. Now I'm going to go back to red, so hold on a second here. Go back to red. There we go. All right, so what do we have right now? We've got x squared minus 4x plus 4 equals 18. Now what we have just done is we've completed the square. Why are you saying? Because now we can write this left side like that. We're taking half of this, squaring it, and adding it to both sides completes the square on the left-hand side. Now, what is this? Well, very simply, x squared, what is it before it's squared? It's just an x, no problem. The minus here, bring it down. Simple so far, right? Now, what was this number before you did the squaring over here? Well, before you did that, it was a 2. That's how you got the 4. So this factors as x minus 2 quantity squared. Now you're in business. And now we can work it like we did in the last example I showed you. So right now what I'm going to do is, I know it's a quadratic, so I'm going to get 2 answers. So x minus 2 equals, and just as a reminder to myself, I'm going to write it twice. That way I don't do it once, think I have the answer, and that's the end of it. But it isn't. Now what's that equal to? Well, the square root of 18 both ways. The square root of 18 and negative square root of 18. Now let's sneak over here for a moment and take a look at this square root of 18. I'm not going to bother to change the colors. Notice that 18 is the product of one that comes out even and one that doesn't. And this would be 3 square root of 2. So what we've got here is x minus 2 equals 3 square root of 2. And over here, x minus 2 equals negative 3 square root of 2. Now we complete our work. Add 2 to both sides of this. One solution is 2 plus 3 square root of 2. One answer. And if you take this number and put it in this equation, you should get a 0. I showed you how to do that with a calculator. If you're not quite sure how to do it, ask me in class. We can do that really fast. Second one, remember we've got 2 answers. Add 2 to this one, and you get 2 minus 3 square root of 2. After doing some of these, you'll work on this one, and you'll know what the second one is. But remember, write the x minus 2 or whatever it is twice. That way you don't forget about this one. You don't want to forget. All right. Hope you followed that. If not, bring a couple into class and we can do several of these. You want to become very good at this because it's handy, and I'm not going to tell you what for, but it's going to be handy several times during this semester. You can see the steps. Continuing on. And there are your 2 solutions, or roots, or zeros. Remember, you can take one of these, save it in X in your calculator, and then type this in, and you should get a 0 with each one. There's your solution set. So let's try it again. This time, x squared is not a 1x squared. So the first step is to take this, and since we want a 1x squared, we'll divide everything by 9. So we'll have x squared minus 12 over 9x plus 1, because that's 9 divided by 9, equals 0 divided by 9 is still 0. Next, we're going to do 2 things here. I don't think that should confuse you too much. X squared is fine. This can be reduced. We'll make that 4/3 x. And also what we're going to do, we need to leave a blank in here. So I'll subtract 1 from both sides, and we're ready to go. Now, since I think it might help, I'm going to change the color again. And what do? Okay, the number in front of the x, the coefficient of x, the one right here, I'm going to take that negative 4 over 3. Remember in the last one I divided it by 2. Well, dividing by 2 is the same as multiplying by 1/2, remember? And then I'll square the answer. So what do I have here? Well, I can reduce this because I've got a 4 and a 2. So I've got negative 2 over 3, and I have yet to square it. Squaring it, I get 4/9. We're ready to go. Now we're going to take this, add it on this side. That completes this square. And to keep the equality, I'll add 4/9 to the other side. And I'm going to switch back to red again so we're consistent. Where am I? There we go. Switch back to red. There we go. Okay, here we go. Now, we just completed the square. That means we can write it like this. Let's get back to that in a second. Over here, we've got a small problem. We've got a -1 and a 4/9. You can't add those together too easily. But what you can do is you can make this first one -9/9 plus 4/9. So what we've got over here is -5/9. Okay, and then you can forget about this if you like. Okay, what do we have over here? Well, x is what we have before the x squared. That's simple. This minus, just drag it on down. And what was this before it was squared? It was 2/3. You can actually see it over here. Or you can take the square root of 4/9. Square root of 4 is 2. Square root of 9 is 3. There you go. You've completed the square. Now we're ready to solve it. Let's see what we get. Remember, first, you're going to get 2 solutions. So we're going to write this down twice. Oops. Write that down twice. Now, we've taken the square root of the left-hand side real easily. We're going to have to take the square root of the right-hand side, which is the square root of -5 over the square root of 9. Let's simplify that a little bit. X minus 2/3 equals, now on the top, notice we've got the square root of a negative number. So remember that trick I told you? Factor out the I first. This is the square root of -1 times the square root of 5. And this is I. So I, square root of 5, is the top. And on the bottom, just a 3. Very simple. Now what do we have on the other one? Well, we can take a look at this one, and what x minus 2/3 equals the opposite of what we just got for the first solution. Now, let's finish it up. We need to add 2/3 to both sides to get x. So x equals I square root of 5 over 3 plus 2/3. Add 2/3 to both sides. We'll get back to this one in a moment. Now notice that we need to put the real part first, because we need to write them as a plus bi. Remember that? So we're going to write as x equals, and we'll put the 2/3 first. Now, we want to show that this is I. I is actually being multiplied by the square root of 5 over 3. So we'll write this as the square root of 5 over 3i. And there's one of our solutions. Now if we look over here, we can go down through here step by step, or we can take a look at this. This is what I figured out on the left side. So this one is going to be 2/3, because that'll be brought from the left side to the right side. And instead of plus square root of 5 over 3i, we'll have minus the square root of 5 over 3i. Make that 3 look like a 3. And there are your 2 solutions. And you can put them in a solution set. And if you want to, you can combine them. 2/3 plus or minus the square root of 5 over 3i. There you go. 2 solutions. And if you're wondering, yes, you can take this and you can actually put it into your calculator for x. And then take that x and put it into this equation, and you should end up with 0. Okay, I hope you followed that. Steps in a different fashion here. We're doing the same thing though. There, cleaner version. That's after you factor. square root property, and then the solution, both of them. Okay, make sure you get enough practice with completing the square, because if you don't, you won't be able to do it. There are about 3 steps that you have to remember that are different from what you've done in the past, but they're not that hard. Remember, you're going to take the coefficient of x, take half of it, or multiply it by 1/2, and then square that answer. And that'll be the number that you add to both sides of the equation to complete the square. Okay, so we've got our solution. Now, this is if a is positive, and if we leave this as just a, b, and c, we can actually solve and get the quadratic equation. If you like, ask me in class, and I'll actually do it for you in class. Some of you won't care about it. Just remember that this, if you solve it, leaving the a, b, and c there, your x can be solved like this. And there's your plus or minus coming back. This is the opposite of b. Inside the radical, square root, of b squared minus 4ac. It's the a, b, and c up here, and all over. Now this is very important. This fraction bar goes underneath the whole thing. And on the bottom, you get 2a. Those are your 2 solutions for any quadratic equation. Now, if you want to, you could split this up, but usually people remember this one. You could say minus b over 2a plus or minus the square root of b squared minus 4ac over 2a. But frankly, I would keep with this one. Now, before I leave this slide, one word of caution. You must know this. You have to have it memorized. If you're interested, I have an interesting story that happened to me about 15 years ago, and I can tell you how I tried to get a class to memorize it, and one of them pulled a fast one on me. If you're interested, let me know. So there is the quadratic formula. You must know that. Remember, a must be non-zero. If a were 0, then you wouldn't have this at all, and it wouldn't be a quadratic. So this is important. And also down here, if you look at this, well, if you're dividing by 2a, this can't be 0 either. So that's another reason. So remember to extend that fraction bar. Make sure it goes the whole way across. Not just underneath this part. It has to go the whole way across. So let's take a look at the quadratic formula and using it. Well, number one on this, notice that it's not in standard form. The standard form looks like this in general. You got 0 on one side with an A and a B and a C. So we have to convert this so it looks like that. The only thing different is this minus 2 is over here. We need 0 over here. So we'll add 2 to both sides. That'll give us x squared minus 4x plus 2 equals 0. Now we're ready to go. Make a note for yourself. A is 1 because you got a 1 right here. B is -4 because that's the coefficient of x. And C is the last number. That's real easy. And then we'll write this down again. It's probably a good idea, before you actually start putting these numbers in, just write this out for practice. That way you don't forget it. And then start putting in the numbers. And I'm going to let PowerPoint do some of the rest, step by step. So there's your quadratic formula in standard form. There's the quadratic formula itself. And there are the numbers thrown in. Now make sure that you write this whole thing out, because once you have minus signs in there, strange things can happen if you're not careful. Write this whole thing out. Don't try to do part of it in your head. I try not to do that unless I'm challenging myself, because a minus, you might forget and leave that as a -4 because it's already minus. No, because this becomes a +4 because you're taking the opposite of a -4. Inside here, you're squaring -4. So you get a 16 there. Over here, this can sometimes be the trickiest part. If either one of these, here or here, are negative, you can end up with the wrong sign for -4ac. That's the trickiest part, to me at least. Once you put the numbers in for A, B, and C, all you have to do is simplify it, and you'll get your two solutions. Because you've got the whole thing with a plus there is one solution, the whole thing with a minus is the second solution. Remember, two solutions. So there we've simplified it a little bit more, because remember this right here is the square root of 8, which is the square root of 4 times the square root of 2, which is 2 square root of 2. Now notice 2 is divided into both of those. So what you've got is 4 over 2 plus or minus 2 square root of 2 over 2. This 2 gets divided into both parts. So you can factor out the 2's, cancel them out, and there are your solutions. 2 plus the square root of 2 and 2 minus the square root of 2. Easy to check. Put each one of those one at a time into this equation. I would suggest going back to the original here. I would put in x squared minus 4x and make sure you end up with a -2. Use the other solution, put in x squared minus 4x. You should also get a -2 for that one. Next, get a little bit more complex. So first of all, you're going to start with this. And what do you need to do first? First of all, you need it in standard form. You need that 0 over here. Without the 0, you're in trouble, because you need to pick out A, B, and C. What's A? 2. What's B? -1. What's C? +4. And take our quadratic formula, which you're going to memorize. Replace the A with 2, the B with -1, the C with 4, and simplify. So there you go. You have the substitutions. Remember, over here you have a minus, so this will be a +1. This will be squared, so it'll be a +1. And here you got a minus times a plus times a plus. So this will be a negative number. -32 to be exact. So combining those inside the radical, you've got -31. And of course, seeing the square root of -31, the first thing you're going to do is factor out that square root of -1. Like this. And that's all over 4. Split them up. Because remember, your answers need to look, if they're complex, they have to be written with the real part first, a plus or minus here, and the imaginary part second. Okay, now we get something a little bit more exotic. And you might think, oh no, do we have a quadratic equation and a cubic one? No, not really, but we have a way of getting around this. So, I'm going to work this myself. So, see the mistake? That's a 3 there. It was wishful thinking, right? Now the trick is you need to be able to factor that. Some people can't factor it. So how do we factor x cubed plus 8? Well, here's an example. Let's suppose we've got y cubed plus 27 equals 0. How would I factor that? Notice that this is a cube and this is a cube. It's 2 cubed. Over here, this is y cubed and this is 3 cubed. Now, how do I factor it? First of all, think of what it was before it was a cube. Well, before it was cubed, this is obviously a y. Before this was cubed, it was a 3. And there's a plus here, so I'll make a guess. Plus? Yeah, you're right. That's easy. Just take the cube root of this, put them down here, use the same sign. That's the first part. Now, the second part, we're going to use a little bit of logic. First of all, you've got a y here. What do I have to have here if I'm going to end up with y cubed? Well, you're going to have a y squared somewhere, right? And if I'm going to multiply 3 times something to get 27, I'd have to have a 9 here. The question is, what goes in the middle? Well, what goes in the middle is actually very simple. We started with a y and a 3. Those are our sort of atoms, if we go back to chemistry. Those are the pieces that we go together to make this second part over here. If we square this, there's our y squared. Square this, there's our 9. Now what goes in the middle? All we have to do is multiply those two together. 3y. The catch is this will be the opposite sign from the one you see right here. So take these. Those are our atoms, I'll call them. Put those in the first set of parentheses. Use the same sign that we have here in the original. Go to the second one. Take the atoms. Square this, put it in the first part. Square this, it goes in the last part. Multiply them together, it goes in the middle. And then make sure this sign right here and this sign right here are opposite. And you've got it. Now the key here is, I'll give you a hint about this last one, is once you've got this, if this is equal to 0, then you've got y plus 3 equals 0, and y squared minus 3y plus 9 equals 0. The zero factor property. This will give us y equals -3. Hey, this isn't so hard. This one's a little bit more tricky, but remember, you have got the quadratic formula in your back pocket. So you can take the a of 1, b -3, and c of 9, put in the quadratic formula, and you'll get the other y's. Remember, you want 3 because this is a third degree polynomial. You'll get 3 solutions. 1 from here, and the 2 from the quadratic formula. Now, let's go back to work. X cubed plus 3. Well, first thing I'm going to do is say, okay, what was x cubed first? It was originally an x, right? What was 8 originally? It was a 2. Those are my pieces that I'm going to use to put this all together. I'm going to have 2 sets of parentheses. Can you tell me what is going to go in those 2 parentheses? Well, I'm going to use the atoms. I'll put in x, and I'll put in the 2. And this plus right here means I'll have a plus there. Easy stuff. Next, I'm going to take the x. This time I'm going to square it. And I'm going to square the 2. I've almost got it, except for the middle one. What do I do for the middle one? Multiply these 2 together. That'll give me 2x. And I have to make sure that this sign and this sign are different. So this will be a minus 2x. So we can take the x plus 2 equals 0, and the x squared minus 2x plus 4 equals 0, and we're just about there. One solution is -2, and I'm going to leave this to you. You need some practice using the quadratic formula. I'll just tell you a is 1, b is -2, c is 4. There's your beginning. It's in standard form. Make sure you have that 0 on the right. Factor it like I just showed you. Notice again that this and this are going to be opposites. And the first one, that's really easy. The second one, you'll use the quadratic formula to get those 2 extra solutions. A little bit of simplification, and you've almost got it. And there you have it in lowest terms. By the way, don't get so excited about getting these 2 that you forget about the easy one that you already found, the 3 solutions. There's actually a special property that says whatever the power is, the greatest power, that's going to be how many solutions you have. So this has 3 solutions because this is a 3rd degree polynomial. Moving right along. A little bit more interesting because this sort of tests you about whether you can do this just taking it one step at a time. So you want to solve this equation for d. So you want d equals whatever. So I'm going to start. I'm going to rewrite this. Now I want to get d by itself. I'm going to do it the way I would do it. You can do it any equivalent way you like. Because d is on the right hand side and I want to end up with maybe on the left hand side, I'm just going to take one step and I'm going to get d on the left side. Nothing to that, just swap them. You don't have to do it, I do it. Next, I want the d by itself. To do that, I need to cancel out the pi and cancel out the 4. So here's my pi d squared over 4. And I want to cancel out the pi, so I need pi in the denominator. Those will cancel. I also need to cancel out this 4 in the denominator, which means I need that. Now if I'm multiplying by 4 over pi on the left, what do I have to do on the right? Well, I'll have to do the same thing. 4 over pi times the area. Okay, things get a little bit cleaner, temporarily at least. The pi's cancel, the 4's cancel. I've got d squared. I'm in good shape, just like the x squared I had earlier. On the right side, I've got 4a over pi. Now what do? I'm going to take the square root of both sides and reminding myself, hey, I've got two solutions. D equals, I'm going to write these first. That reminds me, when I do the first one, I've got the second one because I've got two solutions. So I need to take the square root of 4a over pi. So let's just start with it like this. 4a over pi. Square root of that. Okay, what do I have? Well, let's put this one in first. 4a over pi. All right, we'll work with this one. Now we've got a 4 and an a. We can split them up. Square root of 4 because that comes out even. Square root of a and square root of pi. So d equals 2 square root of a over square root of pi. And that's one possible way you can write that. Or since those are both square roots, you could write it like this. You could write it as 2 square root of a over pi. One possible answer. That means up here, this one will be the same thing except a minus sign in front. Now, this is pretty good, but there are those who would say, we've got a small problem here, Houston. We've got a square root of pi in the denominator. That is not allowable. That's some people would say that. So we're going to fix that. We're going to multiply that by the square root of pi or the square root of pi. I'm just multiplying by 1. So what does that give me? D equals 2. Now on the top, I've still got the square root of a. And that's the square root of a times the square root of pi. So I've got the square root of a pi. And on the bottom, the square root of pi times the square root of pi is just pi. So we could write it that way. And everyone would be satisfied with that. If you write this one, I'm going to say that's fine. If you write this one, that's going to be fine as well. And if you want to be complete here, the other one will be the same thing except a minus sign out front. There you go. Let's see what the PowerPoint does, because I haven't seen this one. They take a different route, but equivalent. There's a square root property, and there's the 4a up there and the pi in the bottom. And they also multiply by square root of pi over square root of pi. Remember that the PowerPoint person wasn't able to put in the multiplication sign for some reason. That's the multiplication. So we've almost got it, and there's our answer. Our two answers. Okay, let's give this a shot. This is something a little bit different, and there's a trick that I want to show you. So, what are we going to do with this? Now notice you have t squared and you have t. There we go. T squared and t. So it's a quadratic. So you can use the quadratic formula, but you have to get this k on the other side. So you have to write it this way in standard form. That way you get the proper a, b, and c for the quadratic formula. Put those in the quadratic formula, which you're memorizing as we go. So a will replace by r, b will replace by minus s, and c will replace by minus k. Very carefully. So it'll look like this when you do this substitution. Then you need to simplify. Like at the beginning, that minus s will be a just straight s, and so on. So there's your simplified version, and that is it. If you want to, you can write that down twice, once with a plus, once with a minus for your two solutions. And once someone tells you what R and S are and K are, then you can find out what T represents for those particular choices of R, K, and S. Just a note, the variable represents time or length if we're working a word problem. This is in word problems. If the variable x, y, z, or whatever we're using, if it represents time or length, just for example, then when we get two answers, we're only going to use positive square roots, because negative square roots don't make sense in reality. You don't have a negative time normally, and you don't have negative lengths, period. Now, we're going to talk about the discriminant, and that should look a little bit familiar because quadratic formula looks like this. Notice that the part under the radical, or under the square root, is b squared minus 4ac. That's the discriminant. Now, just working with a discriminant, you can find some partial answers. If the discriminant is positive, you're going to get two solutions, and they'll be rational. That means you can write them as fractions. If it's a perfect square, it's going to be rational. If it's positive but not a perfect square, you'll still get two real solutions, but they'll be irrational. You have it like the square root of 2, the square root of 17, something like that. Not something you're thrilled about, but it's still a number, so. Now we're still talking about the discriminant. If that discriminant is 0, then that whole square root becomes 0, and you have one solution. It's actually two of them, but it's a double solution, but they're identical, and it's going to be rational. It'll be minus b over 2a to be exact, because the square root disappears for all practical purposes. Last, not so nice, if the discriminant, just a small reminder here, if the discriminant is negative, then we're going to get two solutions. That sounds good, but they'll be complex ones. That means if you're talking about something like time, or you're talking about length, you won't have any solutions at all, because length does not come in complex numbers. So remember, there's a restriction on A, B, and C. The discriminant is going to tell you that there are two rational solutions if it comes out even. And the two solutions in this case will be irrational numbers, because you've got this square root of 5. If it doesn't come out even, that means it's irrational. You can't write it as a fraction. Rational means you can write it as a fraction of two integers. So let's take a look at the discriminant for each of these. First of all, notice we've got the 0, so we can pick A, B, and C. So pick out the A, the B, and the C. calculate the discriminant. If you want to, you can call it capital D if you want to. And see whether it's positive, negative, 0. In this case, it's an 84. It's not a perfect square. So you can sneak back to the table if you like and find out what kind of answers you got. It's positive, not a perfect square, so you get two different irrational solutions. They'll be rational only if that D, the discriminant, is a perfect square. Now, what do you have to do first with this one? Of course, you need that 0 before you can find the A, B, and the C. And you need the A, B, and the C before you can get B squared minus 4AC, obviously. So write in standard form, and you can get the A, B, and the C. Put those in there. This time, B squared minus 4AC is 0, which means you're going to get one rational answer. And it's going to be a double solution. Last of all, this is already in standard form because you see the 0 there. So you can pick out your A, your B, and your C. 2, -1, and 1 in that order. Put it in B squared minus 4AC, you get a -7. Immediately, because that's negative, it means you're going to have two complex solutions. That means there's going to be an I in there somewhere. And if this is a word problem, you might not have a solution. Because if you're looking for time, the square root of -7, it doesn't have anything that's going to give you a rational or an irrational answer. It's going to be non-real. Complex conjugates, by the way. Well, that's it, folks. That's it for the quadratic equation, and we'll see you next time.